Hi, in this video we will solve several numericals regarding Archimedes principle. We have the first question. It says that a boat has a mass of 1,000 tons and it is floating in seawater. Calculate the amount of water displaced. So in the solution part, what you are required to understand is that whenever an object is floating, it displaces its own mass. So the mass of object it will be equal to the mass of the water displaced. It is mass of the water displaced. So in this case, the mass of object, which is 1,000 tons, will be equal to the mass of water displaced, and this is equal to 1,000 tons. 1,000 tons, which is the answer to this problem. All right? Okay. The other question number 2, it says that an object is hung from a spring balance. It weighs 40 Newton in air and 30 Newton when it is immersed in water. Calculate the upward thrust on the object. So what is upward thrust basically? Upward thrust, it is the upward force that will be exerted by that object when it is totally or partially immersed in the fluid or liquid. So in the solution, we understand that upward thrust basically is obtained by taking weight in air minus the weight while it is in water. The weight in water, so it is now weight in air is 40 Newton minus the weight in water, which is 30 Newton. So the answer here is 10 Newton. So this is the upward force that will be exerted by that object. All right? Okay. The second part of this question is asking to determine the weight of the water displaced. So remember that as far as Archimedes principle is concerned, the upward thrust basically is equal to the weight of the water displaced. So upward thrust, this is the upward thrust, is equal to weight displaced by the fluid, displaced by water. So we have already calculated the upward thrust. So our weight now will be the same as the upward thrust. It will be 10 Newton. Part C, what is the mass of the water displaced? So we can basically also calculate the mass of the water displaced by taking, because we understand that the weight of the water displaced is nothing but equal to mass times the gravitational force. All right? So now you can calculate the mass of this object by taking weight divided by gravitational force. So what is weight? The weight displaced is 10 Newton divided by the gravitational force. You can use 10 also because it is constant. So now our mass here, it will be 1 kilogram. This will be the mass of the water displaced. The other part, it is asking to calculate what is the volume of the displaced water. So in this case, we can calculate this volume by using, we understand that the density, this is the density of water is equal to, we basically take the mass of water displaced, this is the mass of water displaced, divided by volume of the water displaced. So the volume of the water displaced is equal to mass of the water displaced divided by density. So you can now divide because we have mass which is 1 kilogram. It is 1 kilogram divided by the density of water, because the density of water is constant, which is 1000. Sorry, yeah, 1000 kilogram per meter cubic. So if we divide here, the answer here will be 0.001 cubic meter. This will be the volume of the water displaced. All right? Okay. The other part is asking you to calculate the volume and mass of the object. Remember that the volume of the object is equal to the volume of the water displaced. We have said this in the other video. And also we said that the mass of the object is equal to the mass of the water displaced. So we have already calculated the volume of the water displaced. So volume of water displaced is the same as the volume of the object. So the volume now here will be the same like this. It is 0.001 meter cubic, because the volume of an object, it is the same as the volume of the water displaced. But also the mass of the object, this is mass of object, will be the same as the mass of the water displaced. So mass of water displaced is 1 kilogram, so it will be the same. Okay, fine. The other part is asking you to calculate the relative density. Remember, relative density, we said in the other video, that is obtained by taking the weight in air divided by the upper thrust. So in this case, our weight in air, we take weight in air, we divide it to the weight in air minus weight in water. So this is weight in air is 40 Newton divided by weight in air is the same 40 Newton minus weight in water, it is 30 Newton. So if you divide, you get 4, because the relative density has no SI units, because it is the ratio with the same SI units. So here the relative density will be basically 4. All right, okay. So let us see the last part of this question, which is asking to calculate the relative density. We understand that basically relative density also can be obtained by we take the density of substance, we divide it to the density, this is the density of water. Remember, the density of water is constant. So we can say that density now is equal to, because we are having the relative density now is 4, so we take density 4, which is the relative density times the density of water times 1 gram per centimeter cubic. So times 1 gram per centimeter cubic. So our answer there will be 4 gram per cubic centimeter. This will be our density. All right? Okay. Let us see the last part of this question. An object weighs 60 Newton in air and 40 Newton when it is immersed in water. What is its relative density and density? So the solution of this question, because we know that relative density is equal to, we take the weight in air, we divide it to the weight in air minus weight in water. So it is 40 Newton divided by 40, sorry, it is 60. Sorry, it is 60. This is 60 divided by 60 minus 40. So this is Newton and this is Newton. So this will be equal to 60 Newton divided by 60 minus 40, it is 20 Newton. So the answer there will be 3, because relative density has no SI unit. This Newton and Newton cancel out. Now you can also calculate now the density, because you are having the relative density, because you understand that relative density is equal to density of substance over the density of water. This is the density of water. So now density of substance will be equal to relative density, which is 3, times density of water, which is, we can use 1 gram per centimeter cubic. So the answer there will be 3. This is 3 gram per cubic centimeter. All right? Okay. Thank you for watching. Don't forget to subscribe. See you then in the next video.